Let's do some word problems. Let's say you have a boat. That's a pretty good boat, I think. And that boat is on the water like this. And over here you have some rocks, right? Pretend those are rocks. And on those rocks you have a lighthouse. Pretend that that is a lighthouse. Now, that lighthouse stands at 100 feet off the water surface. So that's where the light in the lighthouse is, 100 feet off the water. And from this lighthouse, from the light bulb up here in the lighthouse, we can see the boat with an angle of depression of 12 degrees. What does that mean? It means that if you make a horizontal line from the bulb and then a line to the boat like that, the angle in between those two lines will be 12 degrees. That's what we call an angle of depression. Okay? Angle of depression. That means that the angle here is also 12 degrees because of the Z pattern, right? You have a Z pattern here, so if that's 12 degrees, this is also 12 degrees. And sometimes this 12 degrees down here at the bottom, that would be referred to as the angle of elevation, because that's the angle that you look up with to see the higher up object, right? The light bulb. And now the question is, how far away is the boat from the lighthouse, approximately, right? So what do we do? Well, in essence, what we have here is a triangle, right? You have a triangle that looks something like this, with a 90-degree angle. Now, this is obviously a real-world problem, so it's not perfect, but we're simplifying it, right? So you have a triangle, this is 12 degrees, and this is 100 feet, this length right here. And so the question is, what is this length on the bottom? What is our base? Well, that's the adjacent side, right? It's adjacent to that 12-degree angle, and we can use our primary trig ratios to solve for that side. 100 feet is the opposite side. We're looking for the adjacent. That tells us we should be using tan. Tan of 12 degrees is equal to opposite over adjacent, so 100 over the adjacent side. Using our algebraic skills, we can isolate for the adjacent. Just swap it with that tan 12. So you'll have the adjacent side is equal to 100 divided by tan 12 degrees. And if you calculate this, you'll find that the adjacent side length, or the distance between the boat and the lighthouse, is approximately 470.5 feet. And that would be your final answer. Let's do another one. Let's say you have a wall. Here's the ground, and we have a ladder. That ladder is just going like that. And that ladder, we'll call it ladder 1, L1. We'll say that ladder is 12 meters long, so it's a pretty tall ladder. But to reach that same point, let's say you use another ladder like this. And that longer ladder, we'll call it ladder 2, L2, is a length of 18 meters. So you have an even longer ladder here to get to the same height, right? And let's say that long ladder, to get to that height, you have to have it at an angle of 34 degrees. My question is, what angle do I have to set the shorter ladder at? Right, we'll call that angle theta. What angle is that in order to reach the same height that the longer ladder reaches? Right, and again, we assume that the wall and the floor make a 90-degree angle. So how could I figure this out? Well, one thing you could do to start is by analyzing this large triangle here, right? Because the large triangle, right, this big triangle going around the whole thing like that, that big triangle, we know the hypotenuse. The hypotenuse is 18 meters, right? 18 meters. And we know this angle is 34 degrees. And so with those pieces of information, we can find the height, right? Using sine, I'll say sine of 34 degrees is equal to opposite, which is the height of the wall, so I'll call it the wall, right? That's your wall. Opposite over hypotenuse, which is 18. Okay, multiply by 18, you find that the wall is equal to 18 times sine 34. That's going to come out to about 10.0655 meters. You can round your answer, but I'm going to keep it with that many decimals just to make my final answer more accurate, because again, this is not your final answer. The question is, what is this little angle in here? So how do I find that little angle? Well, I know this length here, the wall, we just found it, and I know my hypotenuse, right? Because now we're working with this smaller triangle here. In order to find that little angle, we're using small triangle. So we will do essentially the same calculation, right? Sine of theta equals opposite, which is your wall, or 10.0655, over the hypotenuse, which in this case is 12. Sine inverse both sides, so theta equals sine inverse of 10.0655 over 12. Calculate that, and for your final answer, you will get theta to equal approximately 57 degrees. And that's your final answer. Meaning that if you have a 12-meter ladder and you want to reach a particular height, you can just set it to an angle of 57 degrees. And if you have an 18-meter ladder, you can set it to a smaller angle, 34 degrees, and reach that same height. Now, in practicality, in real life, you wouldn't do this because a ladder has to be set at a particular angle to be safe, but for the sake of the question, that would be your final answer. Let's do one more. Here's the ground, and up above the ground we have a hot air balloon. So I'm going to do my best to draw a hot air balloon. Something like that. And we'll say that this balloon is at a particular height off the ground. We don't know what it is though. Maybe we have to find that. Now what do we know? Well, there's a guy over here on the ground, and he's standing, we know this, he's standing 20 meters away from just below the balloon. So there's a rope you can imagine below the balloon going to the ground. He's 20 meters away from where that rope hits the ground. And there's another guy up here in the balloon. And he's looking out onto the horizon like this. He's looking straight out. Then he looks down at the guy down here. And he figures out that there's a 15-degree angle of depression. Remember, we discussed angle of depression in the first question in this video. So he's looking down 15 degrees and makes eye contact with this guy on the ground. And so the question is, how high up is this balloon? Well, again, we've essentially just made a triangle, right? Just like this, where this is 20 meters. And then that 15 degrees, because of this Z pattern, you can say this down here is also 15 degrees. So this little angle here will be 15 degrees. And the question is, what is the height? So I'm looking for the opposite. I have the adjacent that tells me I should use tan. Tan of 15 degrees is equal to the opposite over the adjacent. So 20 tan 15 degrees is equal to h. Therefore, h is equal to, if you calculate this, 5.36 meters, again approximately. So that's how high the balloon is up off the ground.